In this problem, I'm given a bunch of currents in this generic circuit, and I want to find two unknown currents, I1 and I2. I can do this by applying KCL. A couple of notes about KCL. I can apply KCL at any node I want to. Second, I'm given positive current directions on all of my values. Those indicated current directions define the variables, and I have to stick with those directions. However, when I'm writing KCL, each time I apply KCL, I get to choose whether positive currents enter or leave the node. So setting the sign convention at a KCL application is arbitrary. So now let's use KCL to determine the current I1. First, I have to define nodes. This is a node. I'll call that node A. This is a node. I'll call that node B. This is a node, which I'll call node C. And this is a node. I'll call that one node D. Now let's do KCL at A. And I'll assume that positive currents are going to be treated as entering the node. Remember, that particular decision is arbitrary. So if positive currents are entering, I1 is entering, so it's positive. 1 amp is also entering node A. It is also positive. Those sum to 0. They're the only two currents that affect that node. So this tells me that I1 is equal to negative 1 amp. It would be equally valid to do KCL at A and assume that positive currents are leaving that node. That just changes my sign convention when I write KCL. So now I1 is entering node A. That becomes a negative contribution. So negative I1. This 1 amp current is also entering node A, so that becomes a negative 1 amp. It's the opposite to my positive sign convention. And that sums to 0, but I1 is still equal to negative 1 amp. You can also use KCL at C to get the current I1. Again, I can assume that either positive currents are entering or leaving the node. I think for this case, I'll assume positive or entering. In that case, this 2 amp current is entering node C. That's positive. I1 is leaving, so that becomes a negative contribution. And 3 amps is leaving in this direction. That also becomes a negative contribution. That sums to 0 because those are all the currents that are entering or leaving node C. So again, I1 is equal to negative 1 amp. Now let's find the current I2. I2 affects node B, so I'll do KCL at node B. I think I'll assume that positive currents enter. In that case at B, I2 is entering, so I2 is positive. That agrees with my sign convention. 1 amp is leaving. That's the opposite, so that's a negative 1 amp. And 6 amps is entering, which becomes a positive contribution. If I solve this for I2, I2 is equal to negative 5 amps. Again, I could do KCL at B and assume that positive currents are leaving. That just changes the sign on all of the terms in this equation. So at node B, 1 amp is leaving. That becomes positive. I2 is entering. That's the opposite to leaving, so that becomes a negative. 6 amps is entering, which is also a negative contribution, but I2 still turns out to be negative 5 amps. Finally, let's look at KCL at D and assume positive currents enter again. So at node D, 2 amps is leaving. That becomes a negative contribution. 3 amps is entering from down here, so that's a positive 3 amps. I2 is leaving node D, so that becomes a negative I2, and 6 amps is leaving node D, which becomes a negative 6 amps. So minus 2 and minus 6 is minus 8, plus 3 is minus 5, so I2 is again equal to negative 5 amps. KCL is keeping me out of trouble. I get the same answer regardless of which node I use or the sign convention.